Welcome to this lesson, and to factorize a quadratic trinomial that is a perfect square, you need to be able to recognize that it is a perfect square first of all. And a little background on this formula, which is the perfect squares formula for expanding a bracket like this, which makes it a perfect square because it's something squared, and that's equal to a squared plus 2ab plus b squared. And using that formula to expand x plus 3 all squared, you get x squared, x being the a in the formula up here, in the formula here, and b being the 3. So following the formula, the next part would be 2 times x times 3 plus 3 squared, and that would equal x squared plus 6x plus 9. So what happens if you're given this, and you know that's a perfect square because it started off as something all squared, which means it's a perfect square. How would you know that this is a perfect square? Well, all you have to do is look at the coefficient of the x, which is 6, and go 6 divided by 2, and then square it, and if it equals 9, then it's a perfect square. So 6 divided by 2 is 3, so that's 3 squared, which does equal 9. So that means that that trinomial is a perfect square and can be factorized to that. And a couple of examples. So if you have x squared plus 10x plus 25, and testing to see whether it is a perfect square, so 10 over 2 all squared, that's equal to 5 squared, which does equal 25. So that means that this can be factorized as a perfect square into square root of x squared is x. What number squared equals 25? The answer to that is 5. And this sign here being a plus, that means that's a positive here. So x squared plus 10x plus 25 is a perfect square, and it can be factorized to that. Another example, x squared plus 16x plus 64. And testing again, coefficient of x is 16, divide that by 2 and square it. That's equal to 8 squared, which does equal 64, which is this term here. So that means that that can be factorized to x in brackets plus 8 all squared. So that's how you do it with this formula. The one I'm going to look at now is when it's a minus b all squared, and I'll show you how to do that. And the formula is a minus b all squared equals a squared minus 2ab plus b squared. So when you have something in a bracket like this with a negative and it's squared, always this middle term will be negative and this last term will always be positive. And using that formula to expand something like x minus 4 all squared, that would give you x squared minus 2 times x times 4 plus 4 squared, and that's equal to x squared minus 8x plus 16. And once again, how do you test if that's a perfect square? As long as this is a plus and this is a minus, and this term always will be a plus if it's a perfect square, you just do the same test that you did in the first example when the formula was a plus b all squared, and you just go 8 divided by 2, and you can actually ignore this minus, or you can include it. You get the same result. So 8 divided by 2 is equal to 4, so that's 4 squared, which equals 16. And if I actually did minus 8 on 2 squared, that's equal to minus 4 in brackets all squared, which equals 16 anyway. It's just a little bit quicker leaving out that minus. And so that means that this is a perfect square. If you started with that, then you would know that that could be factorized back to this x minus 4 in brackets all squared. So a couple more examples. X squared minus 12x plus 36. Once again, this being positive, that being negative. It could be a perfect square, and to test it, just go 12 divided by 2, all squared. That's equal to 6 squared, which equals 36, which is the middle term, sorry, the last term. So that means that can be written as x minus, and the square root of 36 is 6, x minus 6 all squared. One more example, x squared minus 20x plus 100. So testing to see if it is a perfect square. Once again, this is positive, so it could be a perfect square. And getting the coefficient of x, or just the number part of the coefficient, so 20 divided by 2 and square all of that, that's equal to 10 squared, and 10 squared equals 100, which is the last term here. So yes, that is a perfect square. So once again, the square root of x squared, which is x, goes there, and what number squared equals 100? That's 10, and all squared, and this sign here being a minus, that's a minus there. So that's how you use the perfect squares formula to factorize a quadratic that's a perfect square, by doing this little test to see, first of all, if the quadratic trinomial is a perfect square, and then if it is, the square root of this number or this term goes here, and the square root of the number at the end goes here, and whatever the sign is here goes in between those two numbers in the bracket. So that's about it for this lesson. I'll see you in the next one.